if we go on the next slide, to give you a bit more background, at Lonza, we see predictive analytics really something that will complement controlling activities going forward, and it's now time to invest and explore and learn. And so I want to share the case study where we have invested significant time at the beginning to look what are the different use cases, how we can use it, what is the saving, how can we benefit from it, and then how to deploy it. And the main objective was, on one hand, to improve automation. Secondly, improve also the forecasting accuracy we do in FP&A. And then thirdly, I think most importantly, to learn this new concept and build up the capabilities. So now I want to go into more specifics on how we selected what we want to do. And for that, we can go to the next slide. What I would recommend before you go and jump into different areas, because you probably have a lot of ideas where you can use machine learning and IA into controlling and business activities, I encourage you to spend a bit more time to think about holistically where you want to invest first and build capabilities. And to do so, we looked at different use cases that we thought we can use machine learning and IA. It is from SG&A forecasting, net working capital forecasting. We had a lot of production variances at Lonza, also revenue forecasting. But before we jumped into an area, we basically looked what is the benefit of doing it. On one hand, from a business perspective, so where could we make better business decisions if we have more accurate information? But then also from an automation and compliance perspective to understand, where can we save a lot of time? At the moment at Lonza, for about 40 controllers are doing a monthly outlook. So where can we save the time for those 2 days? And then improve the compliance. We also looked how difficult it is, and then you need to understand, do you have the data to do the learning? Do you have the process, the stability? And then you understand that some areas will be more difficult than others. So we spent about 6 weeks to do this work, and then we decided to go what is on number 2, the net working capital forecasting, because this is something we considered a quick win, and we wanted to be sure, we have a success when we start to then go into more difficult areas. On the next slide, I can explain you how we approached it. So net working capital, it's mainly inventory, receivables and payables forecasting. And to do so, on one hand, you need the data input. That means you need to collect the historical data, ideally 2 to 3 years back, that you had a lot of data points on different drivers. It can be CapEx, it can be payment, it can be revenue, so that you build this data input. Then we started with what Hans said before is the machine learning part. So there are different algorithms that you can use on a time series to make a forecast. That's the number 2. And on top, we built what is called IA. So we started to combine the different forecasts and that the system can learn over time to understand what are the right predictive machine learning algorithm to take. And once we had it, we had to clean up the data and review certain outliers and remove that. So this was the system we built. It took about 4 weeks to build it for the receivable and payables. Then you probably ask, what is the result? Was it worthwhile or not? And as we are in finance, we can go into the next slide, right? And we spend a lot of time to measure also the accuracy. So on the left-hand side, you see 2 bars. You see the dark bar, and this is basically that judges the accuracy of our organization in forecasting with the past manual process. And the red one is then the machine learning process. So I think what you see that both processes are relatively accurate. So we're above 80% accuracy. It depends by division. Some are a bit higher, some lower. And I think the encouraging part for us was that the fully automated machine learning approach delivered at least, similar level of accuracies, but with a lot less effort. And we also expect, once we learn more, that it becomes more accurate. So that was a quite encouraging results. And then based on this result, this is also something that I encourage you, is to deploy it in your systems. So we use, for instance, SAC as a planning tool, and then we really embedded the machine algorithm that it's already pre-populated with the forecast, and with that, we save a lot of time in doing the forecast. So this is basically the results of our approach. And then on the next slide, I want to share some of the key learnings. I think first of all, it's very important. This is really a journey and we need to experiment over time and learn more. So this is not something you can do 3 months and it's done, but it's something I'm convinced it will take several years and it is a continuous journey. The most interesting part, and Fabrizio will talk in more detail about it, is how to deal with this black box. Because when you have a machine, it gives you and says the number is X. Before, you did an analysis and you could explain why it's X. And this is a fundamental difference is what I put into the number 3, digital transformation means cultural change. So it's a different way to explore because on average it's better, but you cannot explain it and you need to trust, and that needs certain experience. In order to make that change, we decided to run in parallel the machine forecast and the manual forecast, and then over time replace the manual forecast with the machine forecast. I think beside number 3, a few other areas I want to give to you is, on one hand, really spend and invest in in-house capabilities. It is a different way. You need to have more data capabilities, more programming capabilities. So start to hire the talent and make the training that the organization can learn. The second one, data quality. You can imagine if you're a large organization, you have a lot of structural changes, you need to have a long time series. So it's often not easy to have this data. You might have a lot of master data change, but think about when you build a system that you generate the data sets that you have the basis to learn, that you can build on it. Then, number 4, this is something I outlined before. Think about what you need on the infrastructure. Can you really embed it in your forecasting tools that it's helpful, or is it another tool and then you have another set of data that is not consistent? Then on the 5th one, it's be careful and mindful what you do first. We decided to go with the easy one on the top right corner, the quick wins, and then go into more difficult parts in the future. If you start with the difficult areas, you might be at risk not to progress or to disappoint, and then you lose momentum. And with that, I think it's really something that is exciting to me because it's a trial and error, and you need to accept that sometimes it doesn't work and sometimes it works, and you cannot fully explain why it works in one case or not in the other. But I really encourage you to have this trial and error DNA and also expect that certain failures continues with the progress. With that, I hope I gave you a short overview about our use case.